Okay, panel, I'm going to start the program and welcome our attendees. So good evening. Welcome to the Clackamas Area Interceptor Improvement Project presentation. My name is Shelley Perini. I work for Clackamas Water Environment Services, and I'm going to be your facilitator this evening. Thanks for joining us. Next slide. So I'm just going to go over a few quick of the event guidelines. Just a reminder, the event is being recorded. Your microphones are muted. Please use the chat function to ask questions and click on the chat button and type your question. Questions will be answered at the end of the presentation. Next slide. Okay, sir. So before we get into the program, I'd like to take a moment and introduce you to the project team, an important element of this evening's presentation. And I'd like to start with Greg Geist. Greg, can you introduce yourself?
Hello, everyone, and thank you for being here tonight. My name is Greg Geist. I'm the director of Clackamas Water Environment Services.
And Jessica, our project manager.
Good evening. Thank you for joining us. My name is Jessica Renner. I am an engineer in the capital group at Water Environment Services and the project manager for this project.
Michael?
Hello, everyone. I'm Mike Rice. I'm a senior civil engineer with Water Environment Services, and I'm supporting Jessica on the project.
Zach?
And I'm Zach Kolomeyer. Will be the construction manager on this project.
Terrific. And now I'd like to move to our consulting team. Eric, will you start?
Yes, thank you. My name is Eric Wologorski. With Carollo Engineers. We are the prime consultant for this project, and I am the project manager for this project.
Thank you. Corianne.
And I am Corianne Burnett, also with Carollo, and I am the deputy project manager for this project. Thank you.
Wonderful. And behind the scenes, we have Kimmy Sloop and Katie Wilson of Consor, who will be supporting us this evening, and my colleague Todd Logan from our Public and Government Affairs Department of Clackamas County. Next slide, please. Okay, the agenda, just want to do a really quick review. We're going to have an overview of WES by our director. Then we're going to get into a deep dive into the project with Jessica and the team, a highlight of the schedule and activities to date and what's coming in 2024. Then we're going to open up to all of you. And in total, this should take us about 30 minutes to get through the presentation. And then we'd like to listen and learn. Next slide. All right, Greg Geist, I'll turn it over to you.
All right, thank you, Shelley. Again, my name is Greg Geist. I'm the director of Clackamas Water Environment Services. I've been here for about 12 years, and I just want to say that we're very excited about this project and being able to share it with you tonight. We're very proud of the work that we do for the community as far as treating wastewater and surface water and doing habitat restoration work, and feel very fortunate to be able to do it for the community. I also think this project is a good example of how we're planning and delivering and building for the future. So with that, I will introduce a short video of kind of WES in a nutshell.
I love so many things about Clackamas County. There's so many opportunities for recreation and the people are amazing. But what really sticks out as special for me is the water, our lakes, our streams, our rivers. There's something just magical about water. It's as important as the air that we breathe. It provides our health. It provides our food. It provides our sustenance. We need to make sure the rain that falls on the ground is clean and safe by the time it reaches our rivers and streams. We call ourselves a learning organization. We need to innovate all the time. We always want to try to get better. And for us, a lot of that is connecting with the community, understanding what their values are, what their priorities are, and making sure that we're positioning ourselves in a way to provide that for them. We don't call our facilities sewage treatment plants. We call them water resource recovery facilities because that's what they do. They make clean water, that's very important. They also make energy, electricity with what goes down your toilet. And we make fertilizer that we can use out on agricultural fields. People expect clean water. They have high expectations around that. And the idea that we can help protect that, and that's our job, how lucky can a guy get to have that be your job?
All right. So yeah, again, thank you. So I will start with our vision and mission. I'm going to read our vision. I'll let you read our mission. Our vision is to be a collaborative partner in building a resilient clean water future where all people benefit and rivers thrive. And I really think the operative terms in here is a collaborative partner. That's what we're trying to do here. We want to reflect, as I mentioned in the video, the values and the needs of our community. This project that we're going to be talking about tonight is necessary and reflective of our need to grow as a community, and in particular, Happy Valley to grow as a community. And we'll talk a lot more about that. But I just want to say this project, a particular project, is very much aligned with our vision and with our mission. Next slide. So just for those uninitiated, WES is a service district that does wastewater services, surface water services across a regional area, including Milwaukee, Happy Valley, all the way down to Oregon City, Westland, and kind of everything in between. We serve about 200,000 people, and we treat about 7 billion gallons of wastewater per year. When we take what goes down your toilet, and like I said in the video, we make clean water, we make energy, electricity, and we make a natural fertilizer that's used on agricultural fields. One of the things I wanted to emphasize is this, we're going to talk about this project. It's primarily a growth-related project. It's necessary for the future of Happy Valley and the future of our regional infrastructure. Next slide. So this project is not doesn't come out of just thin air. It's a product of a lot of thoughtful planning. So back for the last 6 years, back to 2017, we've done a series of really comprehensive, what we call master plans, which is a kind of a deep analysis of what our infrastructure needs are, what our condition assessment, what our condition of our infrastructure is, and what our needs are for the future. And what I want to call your attention to is the one second from the left, the sanitary system master plan that was completed in 2019. And that's really what identified the need for this project. And so that master plan looked at the many hundreds of miles of pipes that we have in the ground that lead to our treatment facilities, and said, well, what condition are they in, and what do we need for the future? And this project was sprung from that very deep and very thoughtful master planning analysis. Next slide. When we think about what our capital needs are, like I said, this is primarily a project that we need for future growth and capacity in our collection system. But most of the work that we do is actually more around reliability. We have infrastructure that's been in the ground since the 70s, and a large part of our capital investment is to maintain the assets that we currently have. The other piece, 50-50, 60-40, is around capacity. And again, that's what this project is primarily about, although there are reliability components to it as well. Next slide. So, and again, we try to take a very thoughtful approach to how we present these projects, how we develop these projects, and how we pay for these projects. So what we have is what we call a 5-year capital improvement plan. And that is the kind of a synthesis of all of those master planning studies that we have done, coupled with a financial analysis that determines how we can pay for those projects over time. So we start with a 5-year capital improvement plan. We have an annual capital budget that's based on that. We run that through our financial modeling and forecasting to make sure that we can pay for it and that we can sequence our capital plans in a way that results in reliable and predictable rate increases over time. We propose that budget to our advisory committee. Ultimately, it goes to the Board of County Commissioners for approval. So this is one of many projects in our 5-year capital improvement plan. And again, there's opportunities for stakeholder involvement throughout. And this is really the kickoff of that stakeholder involvement for this particular capital project. Next slide. And I guess with that, we can start getting into the details and what this project really is and what it's all about and where it's going to be and how it's going to unfold. So I will hand it off to Jessica Renner, who's the project engineer for this project. Thank you.
Thanks, Greg. Good evening, everyone. Thank you for joining us tonight. I'm excited to share more details with you about our Clackamas Area Interceptor Improvement Project. Next slide, please. So that name is pretty long, and it does give an idea of where the project is located. It's in the Clackamas area. And for those of you that don't routinely work with sewers, I wanted to make sure we all knew what an interceptor is. The short answer is the interceptor is a really big pipe. A sanitary sewer collection system is made up of a network of pipes. At the most upstream point of a collection system, you have smaller, typically 8-inch diameter pipes that collect wastewater from homes. As the pipes continue downstream through the tributary area they are serving, they combine and get larger. The interceptor is the backbone of the collection system, which all the small local sewers connect to her. The interceptor is usually the largest pipe in a collection system and the last pipe that the wastewater flows through on its way to the water resource recovery facility for treatment. Next slide, please. So why is this capital project needed? As Greg mentioned earlier, WES does a lot of planning to make sure we have the appropriate infrastructure in place to serve our customers and our community. One of these planning documents is the Sanitary Sewer Collection System Master Plan. Master Plan, as you saw in an earlier slide, is a very common document that utilities or service providers use. It is a tool used to evaluate the existing conditions and then project or plan what will be needed in the future. Our master plan has a 20-year planning period. Our last master plan was completed in 2019 and projects wastewater flows through 2040. From this plan, we can then determine when and where in our collection system we need to do improvements to address these future flow conditions. Also at this time, I just wanted to briefly touch on what flow is. I work in sanitary sewer collection systems. Flow is the wastewater that is transported in the collection system to the treatment facilities. When working in the collection system, there are two very distinct flow patterns. One is our dry weather flow. This occurs in the dead of summer when the ground is dry, creeks, streams, rivers are all at their lowest points. Dry weather flow is concentrated wastewater from the homes and businesses that are served by the collection system. It is the lowest amount of flow that we need to transport through our system and treat at our facilities. Dry weather flow is easy to predict. We know how many homes and businesses are connected to the sanitary sewer and how much wastewater these typically generate in a day. So dry weather flow is very predictable. The second type of flow pattern is the wet weather flow. This flow pattern occurs during the wet weather months when the rains are frequent, soils are saturated, and creeks, rivers, and streams are running high. Depending on how wet it is outside and how much precipitation is falling, wet weather flow can be anywhere from 5 to 20 times the amount of flow we see in dry weather. So in our master plan, when we project future flows, we are projecting the wet weather flow and building or upgrading the collection system to handle these larger flows that occur during wet weather. This project, the Clackamas Area Interceptor Improvements, is replacing an existing interceptor with a new, larger interceptor that has the capacity to transport the projected wet weather flows. Next slide, please. I wanted to just point out a few of the project highlights that make this project unique and interesting and difficult. In total, this project covers 5 miles of gravity pipe. In the next few slides, we will look at the project route in more detail, but from beginning to end, this is 5 miles of pipe, and it all flows by gravity. There is no place where this flow is pumped along this route, so we need to make sure the entire length, all 5 miles, is sloped downhill the whole way. This project is also upsizing an existing interceptor. This is not a new pipe in a new territory. This area is already developed, and we will need to continue to provide service while the larger pipe is being constructed. And as you will see, when we dive into the route over the next few slides, we are working in a very congested area with heavy traffic and many existing utilities. Because there is no room for error, we will be designing the entire length of the project before any portion of it is constructed. Then we plan to construct the new pipe in 4 phases or segments. The first phase of construction is the Middle Clackamas Interceptor and is likely to begin in 2026. Next slide, please. So I wanted to give you an overview of how the Clackamas Area Interceptor Improvement Project fits in with the rest of our system in this area. On this project vicinity map, the Clackamas Area Interceptor Improvement Project is the green, orange, light blue, and brown lines in the middle of the map. In the next slides, we will dig into this specific project area much deeper, but since I'm an engineer and I'm very linear, we are going to start at the most upstream point and go with the flow through the system here. In the top right-hand corner of this map, the red line, this is a pipe that's not constructed yet. This is called the Rock Creek Extension. It is a project we are currently starting design of. We plan to construct the Rock Creek Extension at the same time as we upgrade the Middle Clackamas Interceptor. Just below the red line is the dark blue line. This is the Rock Creek Interceptor. This is an existing pipe. This is built. It was constructed in about 2006. It is sized appropriately to handle our future flows. The dark blue line flows into the green line. The green line is the existing Upper Clackamas Interceptor and where the Clackamas Area Interceptor Improvement Project begins. The existing Upper Clackamas Interceptor was installed in 1988. It is not large enough to handle the Rock Creek Extension and the Rock Creek. We need to improve this pipe and upsize the capacity to handle the growth. The green or Upper Clackamas Interceptor flows into the orange line or Middle Clackamas Interceptor, which was constructed in 1976 timeframe. It also is not large enough to handle future flows. It will be the first portion of the Clackamas Area Interceptor Improvements Project that gets constructed. From the orange Middle Clackamas Interceptor, everything then flows into light blue or Lower Clackamas, which was constructed in approximately 1972. This is also part of the improvement project and will be upsized. The light blue then combines with 2 other interceptors not shown on this map and changes to the Mount Scott Interceptor. The Mount Scott Interceptor was also constructed in the early 1970s and flows into a diversion box upstream of the Intertie 2 pump station. At this point, the Clackamas Area Interceptor Improvement Project ends. That's the end of our project extents. Also at this location, the wastewater flow can split and go 2 different directions. It can continue on by gravity through the hot pink Lower Kellogg Interceptor to our Kellogg Creek Water Resource Recovery Facility, or it can be pumped by our Intertie 2 pump station through the light green force main to our Tri-City Water Resource Recovery Facility. West currently has projects underway to upsize and improve the Intertie 2 pump station and the force main, as well as our Tri-City Water Resource Recovery Facility to address the predicted future flows. Next slide, please. So now we're going to focus just in on the Clackamas Area Interceptor Improvement Project. We have set this presentation up to feel like a virtual driving tour of the project. We're going to start at the most upstream end of the project limits and go with the flow to the end of the project limits. So everyone, please fasten your seatbelts. Next slide, please. So our first stop on the tour. We are at the tippity top of the Upper Clackamas Interceptor. This is just east of Great Floors at Highway 212 and 224 split. There is an existing pipe bridge there that bridges across Rock Creek. You can see it in the picture. The large green pipe triangle thing there is an existing pipe bridge that carries our gravity sewer across Rock Creek. We will be designing a new pipe bridge to carry our new larger pipe across this ravine. Next slide, please. So from Great Floors, the existing interceptor runs west, paralleling and sometimes crossing Highway 212 and 224. As I am sure most of you are aware, this highway corridor is very congested with many industries and businesses along the route. It is also very congested with many existing utilities, so finding a space to install a new large diameter sewer will be challenging. And keep in mind, as I will continue to stress, the new sewer has to continuously slope down so that the wastewater will flow freely. If we build half of this and run into a conflict that we can't go around, we're in trouble. We'll have to remove that conflict. We need to slope down for 5 miles. The picture on this slide is at the intersection of Highway 212 and the new Highway 224 Sunrise Expressway. This is approximately where the Upper Clackamas Interceptor ends and the Middle Clackamas Interceptor begins. As we continue west on Highway 212, we are following the route of the Middle Clackamas Interceptor. The interceptor turns north at approximately 102nd Ave by the North Clackamas Bus Barn and winds its way through the streets, zigging and zagging north and west, crossing in front of Camp Withicum to our next stop on the tour. This next stop is also the end of the Middle Clackamas portion and the beginning of the Lower Clackamas. Next slide, please. And then at this point, Zach is going to take you through this stop on the tour.
Good evening, everybody. This is our second actual stop along the tour. At this site, we're just north of Highway 212 and Camp Withicum is just to the east. Just north are the radio towers you're probably all familiar with along the I-205 corridor near the Sunnyside exit. At this site, our interceptor crosses the main railroad line in this area. We will need to employ alternate construction options or alternate routes at this site because it's not possible to dig across or through that facility. There are other issues that go along with this site as far as access, high groundwater, and flat topography that will present some construction issues and maintenance issues as well. Next slide.
Cool. Thank you, Zach. So continuing along our route, we are now following the alignment of the Lower Clackamas Interceptor, and we come to where the interceptor will need to get under I-205. That's what is in the picture above us. In this location, we have an elevated portion of I-205, we have a creek, we have environmentally sensitive areas, and we have the ODOT bike path, which is heavily used by bikers commuting through the area. We are looking at trenchless installation methods to install a new pipe here. Next slide, please. Continuing along the route, we pass Costco and are where the Lower Clackamas Interceptor ends and the Mount Scott Interceptor begins. For those of you that shop at Costco, you might never know this area exists. This next stop on the tour is at the end of Jasmine Lane across from Costco. It is tucked back by the creek and next to the railroad tracks, as you can see in this picture. And this picture was obviously taken in wet weather months where the creek is elevated and almost up to the railroad tracks. This is a low-lying, environmentally sensitive area with wetlands and stormwater control ponds in close vicinity. We also have, if you were able to pan your head and look to the right, 82nd Ave is elevated and crosses the tracks and the creek at this point as well. Again, a very tight, difficult location to install large diameter pipe. A trenchless installation method will be used here to get under the creek and the railroad tracks. Once we are on the south side of the tracks, the pipe will continue west to the next stop on our tour, which Zach will tell you more about. Next slide, please.
This is our 5th stop along the tour. This is the at this site, we're just north of the Intertie 2 pump station, and the two landmarks you may be familiar with are we're just north of Lowe's and the McFarland's landscape off of Highway 224. This is the downstream extent of this project. We do have a project at our Intertie 2 facility to increase capacity to divert flow to our Tri-Cities water resource recovery facility. This is where we have the ability to increase our capacity to meet future needs. This project will work closely, will be closely coordinated with this pump station project. What the key takeaway from this site was the size and magnitude of the pipe currently, and how much larger we will be making it as part of this project. You can see us looking down on the hole, and you could hear and see the magnitude of the flow there. This was the one site that we opened and allowed participants on the tour to look in to the current facility. Next slide.
So as Zach mentioned, the last stop we wanted to share with you, it's not part of our Clackamas Area Interceptor Improvement Project, but it is being upgraded currently by WES. It is our Intertie 2 pump station. This pump station uses electricity to pump sewage away from our Kellogg Creek facility to our Tri-City facility for treatment. The station was constructed in about 2012 timeframe and can pump up to 10 million gallons a day of wastewater. WES is currently increasing the capacity of this pump station and force main to pump approximately 20 million gallons a day to our Tri-City water resource recovery facility for treatment. Next slide, please. So now that we have shown you the route and some of the more challenging locations where this project will install new interceptor pipe, we wanted to give you an update on the schedule and activities. Our project manager, Eric from Corollo, will share this with you. Next slide, please.
Thank you, Jessica. So with a project of this magnitude, as you can well expect, it's going to take many years to design, to identify routes, design it, and construct these improvements. So for this first phase of the project, we are designing all of the pipelines up through a 60% design, so that we can ensure that, as Jessica mentioned, that we can get all 5 miles of this pipe into a location that has the least amount of disruption to other utilities and impacts to the public, but yet also can convey that flow by gravity all the way to the Intertie 2 pump station, or the diversion structure, as part of this project. So you'll see, as part of this schedule, we've started with the field work through fall and winter of this year, and then it'll proceed straight into 30% design of selected alternatives of how we get across some of those challenging features, like the Rock Creek Ravine and under I-205, and then again under the Mount Scott Creek and the railroad that you saw all along the route. We'll also be taking that all the way, again, through 60% design, and we'll be starting to look at any property acquisition that is required that will allow us to construct these improvements. And then obviously throughout the entire length of the project, it's extremely important to keep the public engaged, which is why we're having this type of a meeting, and we'll continue to try and keep the public engaged throughout the design of this project and into construction. Next slide.
So I just wanted to stress to you all that WES is committed to community engagement. Let's face it, construction is not always fun. There will be traffic impacts, there will be noise, etc. And we will do as much as we can to minimize that through our design, as Eric mentioned, the impacts to the community. We will look at design options, location to minimize as much as possible. We also commit to keeping everyone informed so that we can all plan accordingly and hopefully minimize the impacts as well. Eric, can you talk about our ongoing activities?
Yeah, so I wanted to talk about some of the activities that have been going on this year, and you may or may not have seen some of this activity as you've gone along the route that we described. We're starting with a lot of the field investigation work to understand what are the challenges that we're going to deal with in the field, whether that's roadway improvements or utilities that are in the ground. So we've done the land surveying, we've done utility locating. We're working on right now a lot of environmental assessments of creeks, of trees, historic resources assessment. And then also we've done a lot of geotechnical exploration to understand what type of soils we're going to be dealing with and what type of geotechnical impacts we're going to have as we try to do some of these challenging trenchless installations as part of design and construction. So that's some of the activity that has gone on in 2023, and on the next slide you'll see what's coming up.
Yeah. So as we said, we are committed to community engagement. This will continue. We will be coordinating with our stakeholders. We will be coordinating with other utilities. We'll be holding design open houses, and then Eric can talk you through some of the more project related what we will be doing.
Yes. So what's coming up next for us as a project design team? We just recently went through a workshop with district staff and our consultant team to look at a lot of these alternatives of how we get across these challenging locations. Like I mentioned, anywhere from Rock Creek all the way to I-205. So we're working on completing that alternatives analysis and memorializing those decisions that were made. And we're going to finalize those alignments as far as what's the best way to get this 5 miles of sewer to flow by gravity to the diversion structure. Following the completion of that, what we call a basis of design report, which is a 30% design, we're going to jump right into the 60% design, and where we will get into the real kind of the brass tacks of this design and what are some of the utility conflicts and impacts that we're going to have to, challenges that we're going to have to face as we complete the design in the next phase of the work.
Thank you. Next slide. So with that, I believe I'm handing back to Shelley.
Yes, so if we could go to the full group and remove the PowerPoint presentation so that we can see everyone. And we're going to now open it up to questions from the audience. And I see we already have one from William. And Jessica, this is for you and Zach, because you referenced a few times along the route trenchless technology. So what is a trenchless installation? And also, could you add, why are we using it? Why is it important?
Sure. Yeah, trenchless is, there's a couple ways to install pipe. One way is to dig a big long trench and lay the pipe in from above. And that can be done when the surface conditions aren't that difficult. But then there's also multiple trenchless technologies. Trenchless doesn't mean there's no holes. It means there's a lot less holes. There's typically a receiving pit and a launching pit, and the pipe is installed through the ground, whether it's drilled or jacked or bored or whatever technology it is that's used. But there's multiple ways where you don't have to open up the whole length. And that's what trenchless is. Again, doesn't mean no holes, just means less holes. Does everybody agree with that?
Okay, thank you, Jessica. And I see there was a hand raised, Katie. Looks like Richard would like to ask a question. Does he need to put it in the Q&A, or can he?
He can put it in chat, or I can unmute his mic if he's more comfortable with that.
Yes, so let's unmute so Richard can ask his question. Are you ready, Richard?
Yes. On the, how large, what is the diameter of the pipe along 212?
Thank you, Richard. Jessica?
The diameter varies. I believe we're starting at about 36-inch at the most upstream and going to 52-inch at the most downstream. So Eric, do we know, or Corian, do we know approximately the range of diameters in 212?
I believe in 212, it ranges from 36-inch diameter to roughly 42 or 48-inch in 212. We generally don't see the largest diameter 54-inch until we cross Mount Scott Creek, and those interceptors kind of converge by Costco, and then it'll get up to a 54-inch diameter pipe.
And will that be placed in the right of way? I mean, I'm not sure. It looks like it goes right down the middle of the highway. Is that basically?
Yes, understood. We will probably stay in ODOT right of way. We do not have an exact alignment, whether it's to the south side of 212, north side of 212, in the sidewalk, in the center lane. That's part of the alternatives analysis that Eric mentioned. We need to look at the existing utilities and where there actually is space to put this pipe. And then we also consider things such as constructability. You know, we're going to need to put this pipe in the ground and we don't want to disrupt traffic the whole time. But then also we need to operate and maintain this pipe for the next 80 to 100 years. So our own employee safety when we need to get in this pipe. So there's a lot of considerations that go into the exact place that it's constructed.
Thank you, Jessica. Any other questions from the audience? Any other questions? I know when we conducted the summer van tours, the safety and placement were big questions as well. And of course, the preference would be to keep them as safe and tucked in as possible, but we are dealing with an existing system. Do you want to touch on that at all, Jessica? I know that was something you talked about on the tour, because we can't stop the flow. How are we going to manage keeping the flow moving and building this new system?
Which is a good question. And we're still working out all those kinks in design and constructability. We will need to maintain the existing sewer flow while constructing this new pipe. And it will probably be something where the new pipe is constructed in a nearby alignment and then connections are made to switch the existing flow into the new pipe as it's brought online. Eric, Brian, do you have anything to elaborate on that?
No, I think you've got it exactly right. So we're working on kind of that analysis right now. There are portions of the alignment that may be parallel to the existing, where we're able to keep existing flow in. There are sections where we might have to replace the existing pipe in its exact place just due to constraints of existing utilities. Where that happens, we will set up temporary bypass systems that typically you'll see run overground for portions of it and then buried at driveways so as not to disrupt businesses or residential impacts and traffic. So it's likely that there will be a combination when we're talking about a 5-mile long project of parallel or replace in place.
Great, thank you. Thank you, Eric. Any other questions? We'll let the audience think about this a moment. To stay connected and informed, we'd like to invite you to sign up to be on our newsletter so that we can keep you updated on what's happening at WES. Thank you, Katie. Right on time. So if you'd like to learn more about a number of the capital projects or efforts taking place at WES, please sign up. But particularly for those who are interested in this project, that is one of the vehicles we'll be using to keep people informed. And we invite you to stay tuned to our website as well. Anything else, Jessica, Greg, or Eric from the project team that you would like to share before we head back to the garage and let our folks end the tour?
I would just
thank you for your time tonight, and I appreciate it. And like I said, we're very excited about this project. It's a critical infrastructure need, and we're trying to get it, you know, as far in front of it as we can and get as much input as we can. And yeah, that's it. Thank you.
Thank you, Greg. Jessica, final word.
Sure. To echo Greg's sentiment, I just want you to be reassured, be patient with us. I understand construction is not a pleasant experience, and we are trying to do this as respectfully and responsibly as possible. So,
Great.
and please reach out with questions. We're happy to chat. Thank you.
Yes, thank you all for joining us this evening to learn more about the project. And again, if you have any question, thoughts, or comments, please reach out to us, and Jessica or one of her team members will get back to you with a response, and we hope to see you at the next meeting in the future. Have a great evening. Thank you.